Alright, we're now going to look at 2010 paper 1 question 23. This question is a lens question. Let's read the question together. The diagram shows the path of two rays of light from an object. The object is 10 cm in front of the lens in the position as shown. So how am I going to answer this question, and why is the question asking? Which type of lens is it, and what is the focal length? So the first thing is we need to ask is which type of lens is it? So basically they are asking whether it is a converging or a diverging lens. Now how do we know whether a lens is converging or diverging? Is very simple. What you need to do is to look at the rays that are coming out from the object. In this case there are two rays. So what happens is that if the ray is not bent after passing through the lens, it will go straight. So of course this ray will not be bent because it's passing through the optical center. Regardless of diverging or converging, it will not bend. But let's look at the second ray, which is this one. So this ray is a little bit unique. It is not one of the principal rays. Okay, it is not traveling parallel to the principal axis, so it's not one of the principal rays. But if let's say it's going to go through the lens without any lens obstructing it, it will have gone straight through. This would have been the path that the ray has gone. Now if the lens is a converging lens, it will bring the rays closer together, while if it's a diverging lens, it will bring the ray further away from each other from its original path. So from its original path, you can see that the ray has been brought closer to each other. So based on this fact, it is a converging lens. Okay, so the answer could only be A or B. Alright, so the next question is, what exactly is the focal length? Now in order to answer this question, we first look at how these two rays are behaving. These two rays are not able to converge after passing through the lens. So if it's not able to converge after passing through the lens, it means that it will have to converge on the other side, on the same side as the object. So there's only one condition where the image will be formed on the same side of the object, and that is the magnifying glass condition. Alright, so it is very important that you can remember the conditions for all the 6 conditions. So if you can remember, for the magnifying glass condition, alright, the image distance the object distance must be smaller than the focal length, sorry. The object distance must be smaller than the focal length. That means that the object distance here is actually smaller than the focal length. So this distance is actually smaller than f. So f could have been here somewhere, and of course on the other side it has the same distance away. So obviously f has to be greater than 10. So the answer is A. Right? So that's your answer.